Hello and welcome back. Today we have a kind of like different question. It's a limit equation. It's because we have a limit. We know what the limit must be, and we're trying to find something. I mean, what is clearly the equation? Well, the limit is in x, so there should be no x's left here. So that'll be a function of a. So we want basically a is equal to, because of course again these are constants. And that's the eth root of e squared, which looks quite disgusting. A is a positive number. I think I don't know if that causes a problem if it's negative. I don't think it does. It could be it's symmetrical, I guess. But I think it's probably we get some quadratic maybe somewhere and to have a unique solution. I don't know. We'll see how it happens if it's of importance. Okay. I'm not going to treat that as an equation. I'm going to treat that as a left-hand side. And once I simplify this enough and find what this limit is, I'll set it equal to that. At the moment, I don't want to be carrying an equation all the way through. So we're going to start with a limit. Actually, let's start from here. As x tends to infinity. And any results that I'm going to use, I'm going to write them down because I cannot possibly prove every result within the question in order to come up with the answer. For something like this, I'm going to manipulate that because I want to use a very standard result for limits, which is I'll write it when we get to there, or maybe let me just write it down. Let's use a different color pen. What pen shall I use? Let's say I want to use the result 1 plus a over x. Oh, for Christ's sake, I don't have room to write limit now. Limit. Start again. I'm very bad today. It's my last video for today. I recorded quite a few. So, can't wait to finish. As x tends to infinity, coughing is coming as well. It's just ridiculous, really. And then we have, so this is a standard result, not for A level. This is the something that converges to E. You do that at university in class of analysis, and it turns out this, if A and B are ones, that's simply E. So if you had 1 plus, or not A, we had like a 1 there, to the power of x, and you take x goes to infinity, that would be E. And normally you see it with an n rather than an x in there, so it'll be n and n. So the limit as n tends to infinity, this in fact is E. If you have A and B there, it can be proven, and I'm going to use this result without any reference. So let's say a generalized case of that is there. So I'm going to leave the generalized case because almost certainly I kind of like recognize some bits in there, and there's no way it's in there somewhere. So let's manipulate that first of all. So x minus a, so x minus a over x minus a, so I can divide it, and in order to have a plus a on the top, I need a plus 2a here, all to the ax, and let's put another bracket so we can be good. And that's of course is the limit as x tends to infinity, and this is 1 plus 2a over x minus a, that divided by that, that divided by that, all to the ax. And we have a little problem now. The fact I go there 2a, it makes no difference whether it was a, 2a, whatever. It's just another constant. The same doesn't, of course, happen for this. So I'm going to use a substitution. And the substitution I'm going to use is, I want a single variable for that. So I'm going to use let, I don't know if it's visible there, so I'm going to put it here. Let y equal to x minus a, and conversely, x is y plus a. And how does that limit change? First of all, the limit now will swap into y tends to something. Okay, if x goes to infinity, looking at this line here, okay, if that is infinite and we're subtracting a finite quantity such as a, y will be infinite. So that will also be y tends to infinity. And that's going to be 1 plus 2a over y. And now the a will stay as it is, but the x will become y plus a. And that's the x in there. That doesn't look pretty, does it? Hopefully I haven't made any mistake, or still. I hope I'm not going the wrong way with this question. Let's continue a few more lines and see what happens. That is 1 plus 2a over y, and the bracket now will be ay plus a squared. And let's think about what we're going to do with something like this. All right. First of all, using the rules of indices, okay, we can actually write this as 1 plus 2a over y to the power of ay. And then it's a times, because if we multiply, let me just write it down and then you can look at it, to the a squared. Same base, you'll add the exponents. But of course, the limits now have properties. So again, the result I'm using, assuming the limits exist, it doesn't matter to whether it's finite or infinite. Let's say x tends to, I don't know, to k, f of x, g of x. If you had something like that, it's the same as the limit as x tends to k of f of x multiplying by the limit as also x tends to k of g of x. So that's another result from limits which we can use. So what I'm going to do, I need to create a little bit of space. Do I need to go back to the substitutions? The answer is no, I don't think I do. It's like in integration, when you change you use a substitution, you have limits, there's no need to go back to the original number. So we don't need any of this. Just create a little bit of space. We'll have a good laugh if it doesn't work now. Okay, or I write something stupid, something moronic, like I often do. I do apologize in advance for my inadequacies at times. So that is equal to, so now we split this this limit. Limit y goes to infinity, and we go, first of all, 1 plus 2a over y to the a over y times the limit as y tends to infinity. And what was there? That was a squared, wasn't it? 1 plus 2a over y to the a squared. Okay. I think this limit is very easy. It's nothing complicated. Let's look at it. What happens as y goes to infinity? A is finite, so if y gets very large and positive, okay, this quantity here will limit to 0, it will vanish. So we have 1 to a squared, 1 to some finite quantity like a squared is of course 1. So this is now times 1. And for completeness, I can write 1 to the a squared. So I'll have something to write. Check again what I'm doing. This quantity, as y goes to infinity, denominator gets huge. This will vanish. So we have 1 plus 0, which is just 1 to the a squared. So on the next line, that will be 1. This quantity now, we have to compare. Let me just use the brown pen. So let's hope this matches in some kind of sensible way. So we have 1 plus, this doesn't matter, it's a 2a. We have a y there, but that is also y tends to infinity. And then it'll be x, we have an a against. It doesn't say here the number has to be distinctly different. Of course, if it was both a's or both b's, it would be a squared or b squared. So this, looking at this, is going to be e to the power of that times that's your b basically, times a from there. Just check that you follow where the bits come from. I'm comparing with this. So that is your 2a is your a, and your b is also a, so that's that. So the answer is e to the 2a squared times 1. So this limits, in fact, e to the 2a squared. I think that was quite involved, okay? Now we don't forget, we have an equation to solve. So let me just write that what the answer to that one was. That was e to the 2a squared. I think that's from there. It's silly, really, isn't it? I don't think it's anything complicated. I think they try to make the question look very, very scary. Don't forget, I say they. I wrote the question, so I'm trying to sort of like be one of you guys, kind of thing. So I don't want to sound pompous. Okay, so this is it now. So we got e to the 2a squared. That's the limit evaluated now. And this quantity here, rules of indices. So that is a square. So it's going to be written like that. And the eth power is like that. Is that correct? So if you had, forget about e being special, it could be anything. That is the eth, oops, I'm writing 3 is so confusing. The eth from there, root of e squared. Yeah, is correct. It's very easy to make mistakes on this. So we have the same base, e and e. Therefore, the exponents must be the same. Divide both sides by 2. A squared is 1 over e. And I think it could be, of course, plus or minus. If you swap it, the minus at the top and the other one at the bottom, it produces a symmetrical expression. But because here it did say a is a positive number, a is the positive square root of 1 over the square root of e, or if you prefer it, you can write it as e to the minus half. Okay, so that wasn't difficult. The limit was quite involved, though. I thought it was not so straightforward, and it could have gone wrong. Luckily, we did go the right way. Okay, I'm gonna be signing out. So I hope you found this unusual question on limits interesting, and it helps with your enrichment. I will be seeing you real soon with more videos on different topics, and for the time being, bye.